In this question, we are asked to prove that if you take any quadrilateral and if you consider the midpoints of each side of the quadrilateral, upon joining the midpoint with sort of straight lines, or line segments rather, we will get a parallelogram. Okay, so let's see how we could do this. Our strategy is to define a general quadrilateral where the vertices are called A, B, C, D, and to call the midpoints of each respective side alpha, beta, gamma, and delta, and then to introduce vectors, do some vector algebra, and show that actually the shape we get by connecting these sort of midpoints is going to be a parallelogram. All right, so let's dive in. So we start with a general quadrilateral. So we've got A, B, C, and D as our general quadrilateral. Then we want to insert midpoints for each side. And as I've said, so alpha, beta, gamma, and delta are the midpoints respectively. And we want to join these up. So we join these up with line segments. And indeed, the shape we get looks very much like a parallelogram. But obviously, this is not a proof yet. We need to do some more hard work. And we're going to introduce vectors. So we are going to define the side AB as the vector A, the side BC as the vector B, the side CD as the vector C, and the side DA as the vector D. So now we want to write alpha beta, beta gamma, gamma delta, delta alpha in terms of A, B, C, D. Okay, so let's do this one at a time. So alpha to beta, so from here to here, that's the same thing as going from alpha to B and then from B to beta, right? But we know that that red point is the midpoint of AB. So in other words, if this entire vector is A, then halfway, so from A to that red point or from that red point to B is going to be a half A. Okay, so we have a half A. And then likewise from B to that red point is going to be a half of B. So we have a half of B. So we've managed to write alpha beta as a half A plus a half B. So now we repeat this for beta gamma, so this side here. So we want to start from beta, we want to go to C, that's a half B, and then we want to go from C to gamma, that's a half C. So it's going to be a half B plus a half C. All right. We now repeat this for gamma delta. All right. So we want to start at gamma, we want to go to D, that's a half C. And then from D to delta, that's a half D. So we're going to get a half C plus a half D as our vector gamma delta. And lastly, we have delta to alpha. We go from delta to A, that's a half D, and then we go from A to alpha, which is a half A, obviously. So we get a half D plus a half A. So now if I look at two sides, say, that are supposedly parallel, or we expect them to be parallel if this is a parallelogram, let's take alpha beta and gamma delta. All right. Alpha beta is a half A plus a half B. Gamma delta is a half C plus a half D. So immediately looking at these, because the vectors are different, I can't quite say that they're parallel, right? I can't easily write down one as a scale factor of the other. So we're going to have to do some more thinking here. And the extra bit of thinking is we need a way of relating A, B, C, and D. All right. So the vectors A, B, C, and D need to be related so that we can convert this description into that description or vice versa. But actually, I can go from A to A either by just not doing anything, that's the zero vector, or by traveling, as I've said, all the way along the outside. Okay. And when we do that, I go along A, then I go along B, then I go along C, and I go along D, and that gives me the same thing as my zero vector. All right. So now, so knowing this, we can say D has to be minus A, minus B, minus C. In other words, you take all of this to the other side. All right. So we've got a description for D. So what we're going to do is we're going to go to gamma delta and actually replace the D. So we can say gamma delta is going to be a half C plus a half. And here we had a D, but now we're going to have minus A, minus B, minus C, which is what we have here now. And so the half gets expanded in. So we get a minus a half A, minus a half B, minus a half C. And a half C cancels with minus a half C. So now we get minus a half of A plus B. All right. Because we're just going to be left with minus a half A, minus a half B. And that's the same thing as this. Okay. So this is more promising, but we will park that for now. And we will do the same for delta alpha. All right. We want to replace that D with a new description of D. So we want to replace it with minus A, minus B, minus C. And obviously the half is there because we had a half in front of our D. And of course the half A is just there, right? And so we expand this. When we expand this, we're going to get negative a half A. and that's going to cancel with this half a. So the only thing we're going to have remaining is going to be a half times by negative b, in other words, negative a half b, and a half times by negative c, in other words, negative a half c, right? So we will have delta alpha to be minus a half of b plus c, all right? Well, this is now a lot more promising because we have everything just in terms of A, B, and C, and hopefully we can sort of make more sense of this now. So let's take stock. So what do we know? We know that alpha, beta, our vector is a half A plus B. We can check that. It's a half A plus a half B, so half A plus B indeed. And then beta gamma is a half B plus C. And again, we check that, half B plus a half C, so that's the same thing. And then the other two, namely gamma delta and delta alpha, we just worked out, right? We did these by substitution, so these are okay. And now if we compare, so if we compare statement 1 to statement 3, we see that, well, this is a half A plus B, this is a minus a half A plus B. In other words, we can say alpha beta is the same thing as my gamma delta with a negative, right? Now, what does that mean? That means alpha beta goes this way, and gamma delta goes the other way in the same direction. So in other words, these two must have the same size, and the only distinction is one is going in this direction and the other one's going in the exact opposite direction. So they are indeed parallel and of the same size. All right. Likewise, if we compare statement 2 to statement 4, so we see that it's a half b plus c. This is minus a half b plus c. So we can say beta gamma is the same thing as delta alpha with a negative. All right, so in other words, these two opposite sides are actually the same length. It's just that one of them is in the opposite direction to the other one, right? So we can certainly say that, which means we've actually answered this question. We've been able to show that alpha, beta, gamma, delta are midpoints are such that when you join them up, the shape we get, this green shape, is necessarily a parallelogram. All right, so I hope you found this useful. If you did find it useful, then do consider subscribing.